We're going to go over our practice problems for page 301, specifically question number 5, which is a good one to go over. A little bit of a tricky one here. It says when a spring is stretched by 0.400 meters from its equilibrium position, its elastic potential energy is 500 joules. What's the force required to do this? And if the force is changed to 1,000 newtons, how much change in elastic potential energy results from this? Remember that yesterday, or a couple of days ago, when we were talking about Hooke's law and spring potential energy, elastic potential energy, we said there was basically two equations that we end up using. One, F is equal to K times X. That would be the applied force on a spring or an elastic. There's also the restoring force, which is negative Kx. I'm not going to write that down separately because it's pretty much the same thing, but it's a negative number, right? If object A applies a force on B, object B is an equal and opposite force on object A. So if the applied force is F, then the restoring force is negative X. Now the other equation, EP is equal to 1/2 kx squared that we're going to use. We have given to us in this question the displacement of the elastic, or the spring, 0.400 meters. And we have the elastic potential energy is 500 joules, 5.00 times 10 to the 2 joules. We want to find the magnitude of the force that's required to do this. We've only got two equations. What do you want to try first? Whenever I see one like this, generally the first thing that comes to my mind is the equation that has that variable that I'm trying to solve in it. So if I'm trying to solve for F, then I'm pretty sure I'm going to use F is equal to K times X, right? Let's get X. Or sorry, let's get F. But my problem is I don't know what K is. So I have to find another way of finding K. And that's where I'm going to use my other equation. EP is equal to 1/2 kx squared. Let's rearrange that to solve for K to sub into there now. I get rid of the half and I get rid of the x squared. What are we going to do? Adam, what do you want to get rid of here? The 1/2 or the x squared, or both of them at the same time?
Can we get rid of both?
Absolutely we can. They're both multiplied by x, so we can take them over by, right. So it becomes K is equal to EP over 1/2 x squared. Don't go and square root or anything. Unless you're solving for x, don't square root. Just take 1/2 x squared over by dividing. So K is equal to EP, which is 500 joules, divided by 1/2 of 0.400 squared. Now let's do that on a calculator to get a number. 500 divided by, use some brackets on the bottom, 0.5 times 0.4 squared. It's 6250. That's going to be newtons per meter, which now, of course, we're going to take that and sub it back into here. F is equal to 6250 times my displacement of 0.400. Gives me a value for the force of 2,500. So 2.50 times 10 to the 3 newtons. Does that make sense? Now, the reason I didn't write anything down for question B, I kind of want to treat them as two separate problems since we're changing something, right? It's not like we're just finding a second part of the same thing. We're actually changing the potential energy to something other than what it was. We don't want to find the potential energy as a result of question B. We want to find the change in potential energy. But let's get the final first. The initial potential energy given to us is 500 joules. What's the final? Then let's subtract the two to get the change in potential energy. Let's say for question B, EP is equal to 1/2 kx squared. Do we know the value of K? If we've changed the force, does K change? Nope. It's the same spring, right? As long as it's the same spring, K stays the same, and that value would be 6250. The value of X, oh, we don't know. So we got to find it. Hooke's law again, F is equal to Kx, but let's this time solve for F. Sorry, solve for X. The force is 1,000 newtons this time, and K is 6250. So let's get that value. Gives me 0.16. Let's figure out what EP is here now. 0.16 squared times 0.5 times 6250 gives me 80. So my answer, what's my change in potential energy now? What's my change? My final potential energy is 80. My initial potential energy was 500. My change is, good, negative 420. We're going to say it's 80, the final energy minus the initial energy, which gives me negative 420 joules. The negative, again, doesn't mean that, that it's energy to the left. It just means that you've lost energy there.